Hey y'all, we're making sandwiches in here today. So let's take a look at what we've got. So today what we're going to look at is the portion of our introductory lab activity that looks at the scientific method. So that's going to be the purpose of this sandwich making activity. So I want to know what the scientific mindset is. So how do scientists think about problems and then go about trying to find answers to those? So our warm up today is just looking at the engineering design process. So I got a video here, so you'll find that in the warm up section there. And simple enough to explain. So as I take attendance and stuff, we'll watch that video. Then here's the actual activity. So the activity is in the activity section. So we're going to be making peanut butter and jelly sandwiches as a group. So as a side to your sandwich creation, you'll also be creating a video. So what you're going to do is you're going to document your group's process in the sandwich making design process. So just like the video talks about engineering design process, it's the same mindset here. So what I'm hoping for is that as you go about trying to instruct somebody on how to make a peanut butter and jelly sandwich, that you're thinking through all of the different issues that you have to take into account as you're planning what to have them do, how to tell it to them, how to communicate it, how to judge the results, that kind of stuff. So let's take a look at this paper. So this here, I just uploaded the lab instructions as a printout. If you want, you can go to your team and just the files in your general channel there. And here's for day 7, peanut butter and jelly. So you could get this. Here's the rubric for it. So this is how we'll be looking at it. So I'm going to have you guys as a group kind of judge others using this rubric. So let's take a look at what we have here. So here are the different standards that we have. So want to present information and findings and with supporting evidence, want to adapt speech to a variety of contexts, communication tasks, and how well do the answers arguments presented align to the specific questions. So we'll start at exceeds expectations here. So here, each of the content objectives over here were addressed. Additionally, all the information was integrated into a coherent narrative, effectively illustrating your understanding of the connections between the different presentations. Your answers, opinions, conclusions were backed up by at least 2 pieces of factual information. So you meet expectations, you fall a little bit below this, so you don't have the additionally part. So little or no effort is made to find connections in this case. So that's how you would fall below exceeds expectations. So here I give you a bit of an example. For example, the questions are addressed individually or in order, with answers then given and justified, as if you were reading off of a list. So there's no connections made. It's just point 1, point 2, point 3. So you're not making any attempt to see how they all are kind of coherent and fall into the same umbrella. So answers, opinions, conclusions were backed up by one piece. Any incorrect answers were well reasoned and based on factual information. So you may have gotten answers wrong, but I can see why you got those answers. So that comes from your justification. So you gave me justification as to why you came up with what you did. And then below expectations, so you haven't addressed everything here. You have no justification. So your justification provided, but it's not based on factual information. So, for example, in attempting to explain an opinion or conclusion, you say because it makes sense or because I feel like it's correct, that kind of stuff, or because the reading book's notes said so. So, there's our rubric on that. Again, you can find that in the files here. So, let's take a look at the actual objective for peanut butter and jelly making. So, in this activity, each of you will pair with another one. So, you're going to work on your groups. And the purpose of this is to create instructions on how to make a peanut butter and jelly sandwich. So I intentionally chose something here that is very familiar, right? Almost all of you, I would imagine all of you, if asked to go ahead and make a peanut butter and jelly sandwich, will just do it. You won't even think about it. So the catch, if you want to call it that, is you must collaborate on the set of instructions. So this is going to be a collaborative group activity. So just like everything in here. So when one partner attempts to make their sandwich, they must be faithful to the instructions. So you can't ad lib. So when you go about making the sandwich that the rest of your group wrote the instructions for, you can only do exactly what is on the paper. So you can't do stuff if it's not specifically stated on the paper, you can't do it. So the experimenter must do exactly and only what the instructions do. So the end picture that you all have in mind as you write your instructions is the peanut butter and jelly sandwich that's the archetype of the style. So this activity is designed to mimic the process a scientist embarks on a daily basis. So remember, scientists, engineers, inventors are creators. So again, we're all about creation in here. So these are no different than the artists that we saw in our first sets of images last week. So they designed to faithfully reproduce an image of an idea that has wormed its way into their mind. So artists, a painter, for example, sculptor, their work is an expression of what's going on in their mind. So the skill and the talent that they have and the practice that they've put in will be the how do you want to put it? How do I want to put it? So the talent, the skill, the ideas, the practice, everything that they've gained will be the vehicle through which their final picture comes out. So the final picture is only as good as the talent and the skill and the practice that they put in to get to that point. All right, so engineers, scientists, they're the scape or some kind of object in their mind. They have a vision of a mathematical equation or some type of scientific law. But then they have to go about creating the end product. How do they justify that? So they have to go through, they need these same things like we talked about, talent, skill, that kind of, all the practice, the education. And they need to then faithfully come up with a process to reproduce what they think is going on, what they see in their mind. It's just that their final product is not a sculpture or a picture. It's instead a scientific law or a mathematical equation. So that's what we are going to be doing here. In your mind, as you're writing your steps, you have the vision of a perfect peanut butter and jelly sandwich, right? So your goal is to tell somebody else how to produce that perfect peanut butter and jelly sandwich. So along your journey, you're going to record this. So every time one of your group members makes the sandwich, we're going to record that. So this activity is not only about the scientific process, we're also going to get some technology skills in here and some presentation skills and that kind of stuff, just to make it fun. So ending at the sandwich, which is the logical outcome of the signpost you laid down. So if at first you don't succeed, try again. So this is what happens in all scientific experiments. So science is a process of failure and revision. So every time a scientist fails somewhere along their path, they start over and they revise where that failure came from so that they can then proceed past that point. But there is no ending, there's no reaching a conclusion without repeated failure over and over again. So what you're going to see with the sandwich making is the instructions you initially write down will make perfect sense to you because you see the vision in your head, but you're going to fail to be specific enough in various points along the path to allow another person who doesn't see the picture that is in your mind to reproduce that at the end. So this is what the scientific process is about. It's kind of the main thing. And this is, again, one of the main purposes of me in this class is to show you that failure is the only way that we can learn. It's the process of learning. Failure is a natural state within the educational process, and it's not something to get upset or angry or discouraged at. So it's an opportunity to learn, right? So as you go along, as your group member who's making the sandwich fails at certain spots, you take note of that, and then you rewrite the instructions to incorporate your new knowledge into that set of instructions, and then somebody else tries to make the sandwich again. And we just keep repeating this process until you have the perfect sandwich, until you've perfected those instructions. And that's the most important thing that a scientist can do. They have to have the perfect experiment. Otherwise, their outcomes, their conclusions are not going to be relevant. If another scientist cannot look at their instructions and come to do the same experiment and come to the same conclusion, then the results that the original scientist proclaimed to have found are not valid. If the experiment is not repeatable, if the conclusions do not come out the same, then those particular hypothesis or conclusion has to be discarded. So having the correct experiment with the correct procedures, the correct equipment, the correct directions is the most important thing a scientist can do, because without that, their experiment is not going to be repeatable, and thus any conclusions that they think they come to are going to be invalid. So here are the procedures. So you're going to begin by creating a list of supplies that will be needed. So again, this is going to be your list. I'm not giving you anything here. So you're going to label this as supply list 1 and make sure that you include it in your video. So this could be just you filming the supply list on a piece of paper, or you could be more creative about it. And with some video editing, you can type it out and then kind of flash it over or impose it into different cuts on your video. So you're going to collaboratively brainstorm a set of instructions with your group for making a peanut butter and jelly sandwich using the supplies you've assembled. So these will be your first instructions. Now, when you do this, the person that's going to make the sandwich is not going to be included in the instructions. So they're just going to hang out on the side, and the rest of the group are going to do the instructions. So the sandwich maker is then going to, so be sure not to help them out with any instructions. So as the sandwich maker goes about looking at the instructions, again, that sandwich maker can only do what's written on there. They can't come to a point that they know where they know they should do something to make the sandwich, but having not, without it being on there, they're going to do it anyway. Right? So we can't have that. So when the instructions are complete, show us the final product. Says the team, you're going to record yourself as you evaluate the product. So is it true to form, or do you have some tweaking? So what you're doing is you're recording your conclusions. So at the end of the sandwich, you're going to evaluate your sandwich, and then you're going to discuss where things went right and where things went wrong. And at that point, it's time for revision. So again, this is now the engineering design process. So we evaluate our conclusions, and then we go back and we revise where we failed. So we're going to repeat this process. So we're going to keep repeating this process until you have the perfect sandwich there. And at the end, you're going to edit all of these video clips together into a single video. And that's what's going to be uploaded here into our exit ticket. So I'll go to the collaboration section, and we'll put the sandwich up there, sandwich videos up there. So again, this is always a very fun activity. But if we go back to here, you're going to have conclusions. So the very last part of your video is going to be your conclusions here. So these are the questions that I want you to answer. So what was this activity forcing you to do? Why bother making something so simple, so time consuming and challenging? So you could have made that perfect sandwich in less than a minute from the very beginning if you didn't have to write stuff down. But why did we not just do that? So what does this have to do with science? So scientists aren't creating sandwiches. The same thing with artists and junk from the slides. I don't see LeBron James writing instructions on how to shoot a three. They just do it. So throughout this year, I'm going to give you an end goal that I want you to reach. So this is especially true with all math instruction. So instead of, and we'll get into this in a few days, so instead of showing you the goal and asking you to go get it, I'm going to instead give you a set of instructions on how to go about getting that end goal. And again, this is especially true with math. When we do math in here, I give you a set of instructions on how to get to the final answer in that math problem. So why do you think that I'm doing that? And how do you think that this relates to this activity? So when we get to that point and you get angry at me for continuing to ask you what math step you're on instead of just telling you what the answer is, why am I continuing to point you to my list of math solving steps instead of just giving you the answer? So finally, how do you think creators turn an idea that stems from a pattern into a product? So these are the conclusion questions that I'd like to see you do. And again, exit ticket, when done, we're going to stitch the videos together, do some video editing, and then post it to the collaboration page. And then what I'm going to ask you all to do is take the rubric, and you're going to pick one of the presentations, and you're going to evaluate that presentation based on the rubric. that we have there. I don't know what